Hi, okay, we are back with our lightweight math wizard. So our 1.5 billion parameter base model LLM that's been fine-tuned. And earlier we did a test and we saw that we scored on this little test of ours 85%. And we're going to see with the tweaks we've made if this improves. So the output tokens on this one is a lot more. You'll see we can go up to 130,000. It takes about a gigabyte more memory than the smallest one that we used before, but the results are pretty fantastic. So I'm going to show you, we're going to run exactly the same test as we did with the previous version, and this time we can see there's some improvements in the formatting, so we actually properly see the thought process now. So that chain of thought is showing clearly, and we can see for the first result there we've got a hit, so that is looking good. And also the output formatting is slightly better. I did notice in some instances it doesn't always maintain the proper formatting for output, but is looking pretty good overall. So okay, we're just speeding up the video a little bit so that we can see what happens here in terms of the output. So we can see every time we run those tests, we're hitting it, which is really great. In this particular one, however, we managed to not get it in the previous lighter model. So let's see what happens in this one. You can see the thought process has gone for a bit, and minus 98, so it's actually getting this. So it's an improvement on the previous model, and at this point we're just showing that the temperature is set to the lowest because we want more consistency and accuracy rather than creativity. Okay, and then I'll speed it up again and we'll run through the other ones until we get to the end. If you remember correctly, or if you saw the previous video on our lighter model, the first one, it got all of them right except for two. The last one was one of those that it got wrong. So this one is managing to hit all of them. And I have to be fair, I'm a little bit tough on this model. It's going to produce the correct result, but not exactly how we got it from the manual that we base these calculations on. So this one we should get mx and 5. This one is telling us is minus 5, 0, and 5, which is actually correct. So, you know, we're giving a 95%, but technically that's 100%. So at least an A plus on the rather advanced math test there. And what I'm showing you here is just what the data sets look like again. So there's quite a lot happening here. We had to split it up into smaller segments so that it's a little bit more easy to digest and feed into the models. I'm running off my home computer, and it's a pretty decent computer with a decent GPU, but still it's nothing like a H100 or a H200. So you can see there's massive data sets. This one is 4.39 gigabytes, it's quite huge. We don't feed all of that in at once. We split it into chunks and then train and retrain and, you know, continue adding to it. But there are math problems with solutions from various sources that we compile in the format that we need, so that we can systematically train and upskill these models, and every time building on the previous ones. You'll see there's a whole lot of Python scripts happening there at the top of the screen and on the left hand side, because there's scripts for formatting, data sets, training, retraining, converting these models into the proper format. So here you can see we're using the LoRa training library so that we can create our models. We're basing it on the 1.5 billion parameter DeepSeek models, as you saw up there, the distilled models, which is using the Quen base model, by the way. So this is what the extended training looks like. So once we've created the first base model, then we test it, we see what works, what doesn't. Do we have to go back and train it again, or can we extend on the training once that formatting is working? And when it's done, then we want to convert this to a format that we can load into LM Studio. Hope you found that interesting, and talk soon. Cheers.